and the technique for solving each of them is kind of different. Okay, so this is what we are going to observe now, that how exactly we are going to solve different kinds of differential equations. Some might be simple, some might be using some method where we use particular integral, somewhere it is a homogeneous equation, somewhere it is a non-homogeneous equation, and so on. So in our last class, last few classes we can say, we have seen that if we have an equation which is something like this, where on one side it is 0, okay, if we basically have something as 0 here, so basically we call it as homogeneous equation. Now homogeneous equations are more easy to solve, right? So this is the more or less homogeneous equation. But when we have some other terms on this side, like for example we say, let's say this is e to the power x, this is an example of non-homogeneous equation. So the technique for solving both of them is different. Okay, so what we are going to see is, we are going to see different kinds of ordinary differential equation and how we are exactly going to solve them. Okay, so it may be a very simple differential equation. There is only one independent variable. For example, it can be t or x. Okay, it is an independent variable. For example, if I want to differentiate dy dx, y will be a function of x, so x is our independent variable. Here it's a second order differential equation, this is a first order differential equation. So what happens is that it's not that you'll have only one kind of equation, it can be having two or more independent variables. Okay, so then we can actually do the partial differentiation. Many a times it's not that it will have a function of only one, it can be a function of both x and t, x and y, and so on. So we have to do partial differentiation, so that means this partial differentiation has to be done. So this is also there. It can be of linear form, where you can have it in this form. Okay, you have the equations like this. Okay, you have the equations like this, of this form, and independent variable y is there, and its derivative r to the first power. Okay, so basically you have it as the first power. This is linear in nature. Okay, and no complications as such. So you can see this is second order, first order, and then you have got this y value. So it is all first power, it is not square, it is not y double dash square or y dash square and so on, right? So it is first power, so that's why it is linear. On the other hand, if you consider non-linear, it simply means that any equation which is actually not linear, that's it. Linear नहीं है तो ये non-linear हो गया. For example, this equation you can see y double dash is there, but then there is a sign term here. Okay, so that means you cannot consider this as linear. Okay, here it is y into y dash, so that means you take y multiplied by the first derivative of y, so that means this is also not linear, and so on. Homogeneous linear is again y double dash 4y dash 4y is equal to 0, and so on. So these equations are there. Similarly, non-homogeneous linear equation, you have it, but on this side you have a term. Okay, this is not 0, so this term is there, so this is non-linear, non-homogeneous equation. Many a times, if you want to solve for a differential equation, the first order is relatively easy, and as we go to higher orders, it becomes more and more complicated. So we can see a lot of examples. For example, I have an equation like dy dx is equal to gx hy, means it is a function of both x and y, right? So you can consider something like this, dy dx is equal to x y square. Okay, and if I want to integrate this, what I can do is integration of dy by y square. Dy I can bring the y square down, and dx I can take it here, it will be x dx. Okay, so I can take it as x dx. So this way I can do it. So if I integrate dy by y square, it will become minus of 1 by y plus x square divided by 2 plus c. So this is the solution for this. Okay, and you can find out the different forms here. So this is a way to do it, but this is very simple. We have to just separate the variable, that's it. Separation of variables are done. So first order linear equations are also there, like dy dx plus px into y is equal to qx. Now for such equation we have to use the technique of integrating factor. So integrating factor means you take equation. Okay, you take let's say this is your integrating factor mu x. You can denote it by anything, sometimes they write it down as I also. So you can write exponent integration of px dx. So if you consider this example, let's say, okay, we have this equation, separate it out. This is my equation. So this is my px. Okay, this is my px, and this is my qx. Okay, and let me take this marker. So this is my px and this is my qx. Integrating factor is exponent of px. So this is my px. Okay. So if I take this, okay, this is my px, and I can take the integration of this with respect to dx. Now if I do that, I see that the equation will become exponent of this. You integrate this, it will become x squared. Okay, so that means what I can do now is I can simply use this expression, okay, ddx of x square y. Okay, what was our expression here? With px it was y, so I can take ddx of x square y. So this would be nothing but x to the power 4, because our y is with respect to the integrating factor, so we have got this term x square. So x square into x square will become x to the power 4. So I have got this equation. So this we can do. We will see into these problems. Okay, right now I'm not going into the detail. I'm just telling you what are the different kinds of equation that we have. Similarly, we can have these kind of equations as well. Okay, so this also can be solved. But our main aim is to find out the second order differential equation. For second order differential equation, the first thing that we check is whether it is homogeneous or inhomogeneous. So if we say this side is 0, it is a homogeneous equation. That means I can simply write down the characteristic equation. Characteristic equation means in place of y double dash, I can take r, and double dash matlab with square. So I can take a and y की जगह r, y की जगह r, double dash है तो I'm taking it square, plus br. So it is y to the power 1, so br, plus c, then this y is 0, so I'm just taking c, y to the power 0. Okay, so it will be second order, so it will be 2, first order it is 1, and 0 order, so it is 0. So differential. Okay, so r square plus br plus c is equal to 0. So if I do this, I equate it with 0, I can actually find out the real roots. That means I can solve this and find out what are the values of r for which this is valid. And if r1 and r2 are not equal, then I can say that this is the solution. This is the general solution. Please remember this. C1, you can write it down in general, e to the power r1. That means you will solve this, you'll get one variable r1 solution. You'll get the x plus this. So this is there. Sometimes it might happen that you get both the values of r as equal. If you get it that way, you can simply write it down as e to the power rx. There is only one value of r. Okay, you can have both rc and c1 plus c2x. It might happen. Sometimes you might solve it and you will see it's a complex function. So if it is a complex function, you have to write it down as y is equal to e to the power ax c1 cos bx plus c2 sin beta x. Okay, so beta is this, a plus beta I. We'll see the problems and we'll check. I've shown a very simple problem here. Let's say this is a second order differential equation. I'll write it down as r square minus 5r plus 6 is equal to 0. Now if I solve it, I can say that my value of r would be uh, 2 and 3, right? Because if you see this, you can do the middle term factorization. R square minus 3r minus 2r plus 6 is equal to 0. And then you do the middle term factorization, you put 2 and 3, you'll get r value as 2 and 3. So if you put r2 square here, it will be 4, minus 5 into 2 is 10. So 4 minus 10 is minus 6, minus 6 plus 6 is 0. So obviously this is the solution. So if you get two solutions, the solution to this will be y is equal to c1 and c2 will be there. Both will be exponential, but in one it will be rx, r1x, r1 is 2, so I've written 2x plus r2x, that means r is 3, so it is 3x. So this is how you solve. It's very simple there. On the other hand, sometimes you might get a non-homogeneous equation also. That means on this side it won't be 0. It will be actually having some kind of parameter there, some kind of function. Okay. So for this, if you want to find out the general solution, it is a combination of both complementary solution. So this is your characteristic equation. You get this equation here. Okay. This is the solution for this. So you equate it with 0, you get it. And then you find out the particular integral. And you add them both, and then you get the answer. Okay, let's take one example. I'm not going to go into these jargons, but I'm just going to explain. We'll jump to second order differential equation and see what exactly is happening here. If you look into the second order differential equation, this is the most common form of second order differential equation, where on the left hand side it's a function of x, y dash and y double dash, because second order तो y double dash होती है is equal to 0. So it is basically a homogeneous second order differential equation. Okay, example can be of this kind. Second, it can be a partial differential equation, which can again be second order, because it may not be a function of x alone. It might be a function of two variables. So these are all partial differential equations. This is also one more example. Okay, and then we have already discussed linear and non-linear. So let's not repeat this. Okay. There are different ways, characteristic equation and particular integral and so on. So I've just repeated this. So that's how it is done. Let's take some examples to understand the second order differential equation and see if we can actually solve it. So this is very simple. We have an equation like this: a y double dash plus b y dash plus c y is equal to 0. So this is the form that we have, and I want to actually solve it. So for solving it, what I do is I can assume a solution for this, and then I can write down the characteristic equation, equate it with 0, find out the roots r1 and r2, and then just put it here. That's it. That's what we exactly do. Okay. So if I take one example, let's say I have an equation. This is a second order differential equation where y double dash plus 5y dash plus 6y is equal to 0, and I want to solve it. So the first step that I do is, this is the best way to follow. Okay, and simple one by one, ek ke baad ek. The first thing I do is I write down the characteristic equation. Characteristic equation माने y जगह लिखो r, और double dash अच्छे it will be square. So if it double differential, you write down square. It is single differential, so I just write down to the power 1. So f 5 into r minus n third way plus 6. It is 0. It is not differentiated, 0 order. So that means we will write down just 6 is equal to 0. Now I have got this equation, and I can do the middle term factorization, just we have seen before. And I can see that there are two solutions to it, r is equal to 2 and r is equal to 3. Once done, I can write down the general solution. General solution means I can write down simply y is equal to c1 e to the power 2x plus c2 e to the power 3x. So this will be my general solution, and this is the answer. This is a very simple question. It will hardly be 2 or 3 marks question. But how do you verify whether this is the equation solution or not? See, solution simply means that I'll put the result here and I should get 0. That's it. So y I already know, y I found that this is the form of y. I need to find out what is y double dash and y dash. So I can differentiate this equation once. So I'll get y dash. And then I'll differentiate this equation again. I'll get y double dash. And once I do that and I substitute it here, I'll see that my answer becomes 0. So if it becomes 0, then obviously that is the equation. So this is a very simple, clear example where we are talking about distinct real roots, and it is homogeneous in nature. Okay. Similarly, it's not that it will only have two different roots. It might have the same root. Let's take this example: y double dash minus 4y dash plus 4y is equal to 0. So I'll write down the characteristic equation. It would be r square minus 4r plus 4 is equal to 0. So r square minus 4r plus 4 is equal to 0. This is nothing but the formula of a minus b whole square. So it is r minus 2 whole square. Now you see here, its power is 2. That means it has to have two roots, right? Whatever is the power, it will have that many roots. So 2 is the power, so it will have two roots, but it is r minus 2 whole square. That means it will have two roots, r1 and r2 both are equal, which is equal to 2. That's it. Okay. So that means I can write down the same thing. I can write down the same thing as this. Okay. Here it will be 2, r ki jagah 2. Yahan pe bhi it will be 2, r ki jagah 2. But then there will be additional x here. That is very important. There will be this additional term here, x. So this x will be there. Okay. It is a repeated root. It is a case of the repeated root. Okay. If it is cubed, then it will be the same 3 terms, but in place of x, another term will be there. X square will be there in the next term. Okay, C3. So this is how it is done, and it will keep on doing it like this. This one also we can verify. We can take this y value, and we can find out y dash and y double dash. Put it here, and the answer will be 0. This verification is usually not asked. It's just for understanding that okay, we can verify and we can know whether this is the solution or not. Right? Because anyhow we know that this is the general solution for such cases. So such cases will always have these kind of solution. There will always be an exponential term. Okay. Now let's look into the example of complex roots. I told you about complex roots. So let's see. Now let's take this example. Now let's see this. Now this is not a equation because it will be r square plus 4y plus 13 is equal to 0. R square plus 4r plus 13 is equal to 0. Now this is not an equation where you can simply do the middle term factorization or use the formula of a plus b or a minus b whole square and get the answer. It is having coefficient a, b and c. A is 1, b is 4, c is 13. So we have to use that formula where we say that whatever is the variable that needs to be determined, it would be minus b plus minus root over b square minus 4ac divided by 2a. Quadratic equation wala. Quadratic है, square है, so it's quadratic. R is equal to minus b, b is 4, so it is minus 4, plus minus root over b square, 4 square over 16, minus 4ac, 4 into a is 1, c is 13, so 4 into 13 is 52, so it is 52 divided by 2, so it will be minus 4 प्लस माइनस रूट ओवर माइनस 36. अभी माइनस 36 तो रूट है तो वैलिड है ही नहीं, तो डिफाइन नहीं है ना रियल स्पेस में. सो इट इज रूट ओवर माइनस 1, वी कैन टेक इट एज आई into 36 root, so 36 root is 6, so I can write it down as minus 4 plus minus 6i divided by 2. यहाँ 2 कॉमन ले लो, 2 2 कैंसिल हो जाएगा, यहाँ बचेगा minus 2 plus minus 3i, minus 2 plus minus 3i. So that means that it is having a complex root. पहला वाला two different roots, distinct roots, no complex. Second one, both the roots are same. Third wala, we are getting two complex roots. As soon as there is a complex root, the solution is no more simply e to the power rx. The solution will have a cos term and a sine term. So that means in complex root, you can see this is the real part and this is the imaginary part. Now you take e to the power minus 2x, that means you take the e to the power real part. X तो থাকবেই, real part is minus 2, so minus 2, so I'll put minus 2 into you take c1 cos of imaginary part, imaginary is 3, so I'll take 3 plus c2 sine of imaginary part is 3. So this is how you get the general solution when we are talking about an equation which has got a solution which is complex in nature. So this is exactly what we do. Okay, this is Euler's formula as well. Okay, you can expand this if we remember this. Okay, this is also important, but we are going to see that these things we are going to use every now and then, right? E to the power I theta is equal to cos theta plus I sin theta. So if that's the case, we can use the Euler's formula as well. So we can expand this same thing, which is that's it. So these are simple because सारा homogeneous है, इस side में पूरा का पूरा zero है. I don't need to think much about it. Next, let's go to inhomogeneous, non-homogeneous equations. Okay, non-homogeneous equations are important because if there are more marks in question, they'll probably ask you non-homogeneous. Non-homogeneous मतलब same ही है, but इस side में it is not zero, it is gx. So that means if you want to find out the total solution, it will be y is equal to yc. yc मतलब जो अभी हमने निकाला complementary solution जो भी है plus the particular integral. So this is actually done based on the particular integral solution. So you have to add both of them. First you have to equate this to 0 and then find out the solution just like we did before. And second you have to guess the solution and then you have to write down the particular solution. So that is the way that we do. So y double dash minus 3y plus 2y is equal to 5e to the power 3x. So this is the problem that we have and we need to solve it. So first one is simple. We'll take this part to be 0. So we'll find out the complementary solution. This is called the complementary solution when this side is 0 for the homogeneous case. So we'll take it as 0. This will be r square minus 3r plus 2 is equal to 0. Solve it. R is equal to minus 2 plus 2. So r is equal to 1 and 2. So you find out the complementary solution c1 e to the power x plus c2 e to the power 2x. So this is done. Next we have to find out the particular integral. But for particular integral we have to guess the solution. And you can guess the solution correctly if you know what is on this side. So we can see that this is actually an exponential form. So that means my solution which I guess would also be in the exponential form. Okay, so if gx is 5 e to the power 3x, the approximate solution for this, the guess which is mostly correct, would be a e to the power 3x. If you want to do it in detail, it takes more time, but we can always guess this solution. So it would be a, and we don't write down this, with this one we don't know. It will be a e to the power 3x, so we'll take this solution as e to the power 3x. So this is the guess of that solution. Okay, now our aim is to find out what should be a. That is what we need to find out. Okay, so let's find out a. So for this what we do is we can just simply replace the values. See, simply replace the values. I've guessed the solution. My guess solution is a e to the power 3x. So I can find out y. Y is already I know. I've guessed it to be a to the power 3x. Y dash I can find out, and y double dash I can find out. So let's find out what is y dash. Y dash is, if you differentiate this, this is 3 will come in front, a e to the power 3x, 3a e to the power 3x. And y double dash should be 9a e to the power 3x. 9 माने a to the power 3x है, तो ये 3 front में आ जाएगा 9a e to the power 3x. Now I have got y dash and I have got y double dash, and what we do is we replace it here. Okay, we know everything now, we can replace it here. So we can take this as y dash double dash, this is our answer, minus 3 times of y dash, so 3 times of y dash, plus see 2 times of y, so 2 times of y. So what is our y? Y is this a e to the power 3x, that is equal to this 5 e to the power 3x. So everywhere this e to the power 3x is common, so throughout we can get rid of e to the power 3x. Okay, and after we get rid of 3x, we can see that on this side we have got 2a, and on this side we have got just 5. So we can say a is equal to 5 divided by 2. So we find out what is a. So that means our solution is y particular integral is 5 by 2 e to the power 3x. So what is our total solution or total general solution? Complementary solution plus particular solution. Complementary solution is c1 e to the power x plus c2 e to the power 2x, plus particular solution is 5 by 2 e to the power 3x. Just now we found it. So this is the entire. So this is coming in, can be considered to be a descriptive question. The only trick that you need to know is that particular integral निकाले कैसे. उसके लिए you have to know that you are basically playing around with differential equation which is having a solution which can be guessed. Okay, e to the power 3x, so it is guessed. That's better. So this will be around a 5 marks question, maybe. Okay, 5 or 6 marks question. There are other ways of other forms of differential equation which are non-homogeneous. So I can take this equation maybe for example, and if you see this, this is having a complementary solution. Again we equate it with 0, find out the complementary solution, and we get this. See, these are real. Okay, minus 2 is also real. So I can write down c1 e to the power minus 2x plus c2 e to the power x. तो हो गया. अभी particular integral को guess करना है. We have to integrate and find out, guess the particular solution. For guessing the particular solution, what we can do is we can see this form. Now this is in the form of a polynomial. Before it was in the form of exponential. So we guessed it to be a to the power 3x. Now this is in the form of a polynomial. So our guess will also be a polynomial, and polynomial will always be like this. Okay, it is having a square term. So we have to say that there will be a power 1 term also and power 0 term also. So the general solution that we observe is ax square plus bx plus c. So this is what we consider as a particular solution. Okay, eventually we will see that some terms might vanish, some might not vanish, and so on. Okay, but let's just observe this, what exactly happens. So we can find out y dash. So we can find out y dash. Take this, differentiate it once, and you find out what is y dash. Put it there. Y double dash. You take this, differentiate again. So we differentiate twice. It will be 2ax. So it will be 2a. So it will be 2a. So I'll put it 2a. I'll put it in y double dash. Now you substitute it in this equation. And when you substitute, it is y double dash, which is 2a. Y dash is 2a plus b minus 2 into y. Y is ax square plus bx plus c is equal to 4x square. Now here you can see, you can equate a lot of terms here. See, this is only 2a, doesn't have any x coefficient. This is 2ax, okay, minus 2bx. So there is 2a minus 2b into x. So x has got 2a minus 2b. This is alone again, 2x square is alone. And this is a constant, 2a, b and minus 2c. So on this side also you have got this power. So it is 4x square. 4x square के साथ तो इधर एक ही है, minus 2ax square. So that means if you take the coefficient of x square, it is minus 2a. If you take the coefficient of x square, it is minus 2a. On this side the coefficient of x square is 4. So a is minus 2. So this is a very simple way to find out the constant a. Just talk about x. Now if you talk about x, the coefficient on this side is 2a minus 2b. So the coefficient of x here is 2a minus 2b. This side there is no x, so that means its coefficient is 0. So this is equal to 0. So you can check this. A we already know it is minus 2. Replace it here. So it will be minus 4 minus 2b is equal to 0, or b is equal to minus 2. So in this case b is not 0. B is having some term. Next the constant term. Constant term are 2a plus b minus 2c. So it is 2a plus b minus 2c is equal to, this side there is no constant term, so again it is 0. Replace a and b, and then you can find out the answer of c, which is minus 3. So the general solution is complementary function, which is this, plus particular integral. So particular solution, the particular solution is this, ax square. Our a is minus 2, so it is minus 2x x square plus bx, our b value is again minus 2, so it is minus 2x plus c, our c value is minus 3, so this is minus 3. This is done. You can take this, you can find out y dash, you can find out y double dash, replace it here, you're going to get the answer is 4x square. So that is how you can test it as well. Okay. Let's come to the next kind. I am just showing you different kinds of differential equation. You can take a lot of examples, but the best way to understand is take all different kinds of problems, solve it, and that will give you a clear picture of what are the different kinds of differential equation that we have. Okay, next is trigonometric forcing function. So that means it's a trigonometric function. Here it is a second order differential equation, and on this side it is a trigonometric function. पहले निकाल लेते हैं complementary solution. Complementary solution means this side it will become 0, and this side it will be r square plus 4 is equal to 0. So r is equal to plus minus 2i. You can take it to 4 this side and you take it. So you see that this is actually a constant. Okay, and if you recall the solution to this, okay, if you recall the solution to such problem, it is e to the power rx, where r is the real part, into c1 cos, okay, let's say r dash x, r dash is the imaginary part, plus sine c2 है वो इसलिए r2 r dash x, ab r dash x, right? So this is r dash x. Now what is r here? R is the real part. Now if you look into the solution, this is 0, real part is 0, so that means it is e to the power 0. If this is e to the power 0, that means this entire term will become 1, so that means there is no this term. C1 plus r dash x. What is my r dash? R dash is 2, so I'll write it down as 2. Here also it is 2, so I'll write it down as 2. So this is how I can write this. And now we have to find out the complementary particular solution. For particular solution we have to again guess. So I have told you the first one was exponential, so you guess a solution which is exponential. The second one is a polynomial, so you write down a polynomial x square plus bx plus c. If it was x cubed, then you start with ax cubed plus bx square plus cx plus d, okay, and so on. Now this is a trigonometric function, so the best solution possible is this: a cos 2x plus b sin 2x. This is a trigonometric solution. But you see, if you consider this, if you take this solution, it is exactly similar to the complementary function. This is the trick to do it early, otherwise the method is a bit more complicated. But what we are doing is we are guessing the solution correctly. We have to guess the solution correctly. So your instinct might say, yeah, this should be the solution, but this cannot happen because this is exactly the same as the complementary solution, so it cannot be. So what we do is we modify this guess. For modifying this, we multiply it by x, we multiply it with x. So this is how we modify. So this is the trick for trigonometric function. So multiply it with x, तो हम लोग इसको x से multiply कर देते हैं. Now we have got the complementary function, which is kind of different from the particular function, which is different from the complementary solution. So what we do is we take yp, particular one, then उसको first order differential, then you find out the second order differential equation, and then you substitute here. Okay, you only need the second order here, but for second order you need to know the first order, then only you can find out the second order. So you do it. Okay, here you are using the product rule. You've got x and a cos 2x, so you first differentiate x and you keep this same as it is. So a cos 2x into ddx of x is 1. Second, you differentiate this and keep it as it is, so it is will be x, and ddx of cos 2x would be minus 2a sin 2x, so it is minus 2a sin 2x into x. Secondly, you do this with this also, same thing, b sin 2x, and this will be x into 2b cos 2x. So this is how you get this. Then you take the differentiation again this one and this one you can do it directly. Here again you have to use the product rule, okay, and so on, and you simplify it. Okay, I have not simplified it here, you can simplify this and you get the answer. You substitute it here, and then you can see that these are the expression we are getting. You see what is the coefficient of sin 2x here? It is 3. So on this side sin 2x का coefficient है 3, और यहाँ देख लो sin 2x का coefficient क्या है? एक तो है -4 है, so if taken -4 है, and there is no other sin 2x. Yeah, this is there. Okay, this is not, this is x sin 2x. Okay, so let's not take this. and then we have got cos 2x. This is 4b. This is 4b is equal to 0. Okay, and then b is equal to 0. You can do it like this, and you can see that what is your answer here. So that means this is my general solution. B is 0. So where was our equation? Yeah, this one was the equation. B is 0. So this term vanishes. Only this term survives. A we are getting minus 3 by 4. Directly put it as minus 3 by 4 x cos 2x. X cos 2x. A की जगह minus of 3 by 4. So this is the best way of solving this. Okay, this becomes more easy. Okay, next. Cauchy-Euler equations. This will have this form, and we can assume the solution to be y is equal to x to the power m. Okay, the form will be this. This is homogeneous, so this is 0. So let's take this expression example. I'm taking a value as 1, so it is x square y dash. A है नहीं इसका. B I'm taking it as minus 2, so B I'm taking it as minus 2 x y dash minus 4y. This is a special kind of second order differential equation that we should remember. Okay, this will make things easy. So our solution for such equation will always be y is equal to x to the power m. This one you have to remember. Okay, this form is important. So this is important form. Okay, x to the power m. Then you can find out y dash. You can find out y double dash. Y dash should be mx to the power m minus 1. Y double dash should be m into m minus 1. X to the power m minus 2, and so on. You substitute it here. Equate it with 0, obviously. And then when you write it down, you are going to get this expression. Okay, this is the expression that you are getting. Okay, we are not yet there. Step 3, you write down the characteristic equation. So if you check this characteristic equation for this, you see this is y double dash. So in place of y double dash, I can write down, take this as m. So I'll write down this as m square. Okay, and you can in fact take this also. Okay, this sorry, characteristic equation is from this, not from there. Sorry, take it from here. Okay, this you can write down as a characteristic equation. कैरेक्टरिस्टिक इक्वेशन में मतलब क्या हो रहा है, ये x to the power m को तो हम लोग डिवाइड कर रहे हैं both sides में, so like vanishing this x to the power m. So if you do it, it will open this bracket, this will be m square, so m square minus m, so minus m minus 2m minus 4, minus 2m minus 4 is equal to 0. Simplify this, minus m minus 2m is minus 3m, and then you can take common, and then you will be getting m minus 4, m minus 1 is equal to 0. So the solution is 4 and minus 1. So this is the solution. So if you have got two solutions here, you can write down y is equal to c1 x to the power 4 plus c2 x to the power minus 1. So this would be the solution. This is valid for Euler form. Okay, so please